We live in a galaxy with hundreds of billions of stars, each one perhaps holding its own family of worlds. And yet when we look out into that vast ocean of light, we hear nothing but silence. So where is everybody, and why has this haunting question followed us since the middle of the 20th century? In the summer of 1950, a group of physicists gathered for lunch at the Los Alamos National Laboratory, the same place where the atomic bomb had been built just a few years earlier. The conversation drifted toward a topic that had nothing to do with weapons or wartime research. They were talking us about flying saucers, about the possibility of intelligent life elsewhere in the galaxy. Enrico Fermi, one of the most brilliant physicists of the 20th century, and the man who had overseen the first controlled nuclear chain reaction, sat quietly for a moment while the others debated. Then he looked up and asked a simple question that has haunted scientists ever since. Where is everybody? It was a casual remark, tossed out between bites of food, yet it cut straight to the heart of something deeply strange. Fermi was not asking about little green men or Hollywood monsters. He was pointing at a contradiction that nobody in that room could resolve, and the more you think about it, the more unsettling it becomes. Our galaxy contains hundreds of billions of stars, many of them far older than our Sun, and if even a tiny fraction of those stars hosts planets where life could emerge, then the Milky Way should be teeming with civilizations. Some of those civilizations, given enough time, ought to have spread across the galaxy by now, building machines, sending signals, leaving traces that we could detect. And yet we see nothing. Think about that for a second. We have pointed radio telescopes at the sky for decades, listening for any whisper from the stars. We have scanned thousands of planets, catalogued their orbits, measured their atmospheres, searched for the chemical fingerprints of biology. What have we found? Silence. An immense unbroken silence that stretches in every direction. This is the puzzle that Fermi handed to us at that lunch table in 1950, and it now carries his name, the Fermi Paradox. It is not a paradox in the strict logical sense, but rather a question that refuses to go away. How can the universe be so vast, so old, so seemingly fertile with possibilities, and yet appear so completely empty? The contradiction bites hardest when you consider the numbers. Even if the odds of life arising on any given planet are extremely low, the sheer number of planets in the Milky Way suggests that life should have happened more than once. Some estimates put the number of potentially habitable worlds in our galaxy alone in the billions. If just 1 in a million of those worlds produced an intelligent species, and just 1 in a million of those species survived long enough to develop technology, then there should be thousands of civilizations out there right now. And if civilization is common, then we would expect to see at least a little evidence. A stray radio signal, a strange pattern in the light from a distant star, a spacecraft passing through our solar system, anything at all. But the sky is quiet. Every survey, every listening campaign, every careful sweep of the heavens comes back with the same result. Nothing that looks like an intelligent message. It is as if we are standing in a vast cathedral, shouting into the darkness and hearing only our own echo. That contrast between the expected abundance of life and the observed emptiness is what makes Fermi's lunchtime question so disturbing. He was not simply wondering where the aliens are. He was exposing something about our own assumptions, our belief that life is common and technology is durable, and forcing us to confront the idea that one of those assumptions might be wrong. So here is a small exercise for you. The next time you find yourself under a clear night sky, away from the glare of city lights, look up at the band of the Milky Way and let your eyes trace its dusty outline. Think of the uncounted stars, the planets wheeling around them, the eons that have passed since the first generations of stars ignited. Then ask yourself a question, not Fermi's question exactly, but one of your own making. What would it mean if we are truly alone? Or what would it mean if we are not? Write it down, even if it feels strange, because naming the question is the first step toward taking it seriously. The universe does not owe us an answer, but the asking of the question is what makes us human. Fermi's question from that lunch in 1950 was never meant to be the last word. It was the opening of a conversation that we are still having, and the next turn in that conversation leads directly to a set of numbers. If we want to estimate how many civilizations might be listening, how many might be broadcasting, then we need a way to count the unknowns. That is where a man named Frank Drake enters the story, and his famous equation tries to give those unknowns a shape. But the deeper you go into that equation, the stranger the silence becomes. Imagine trying to count the number of civilizations scattered across the Milky Way without ever leaving this planet. In 1961, astronomer Frank Drake proposed a way to do exactly that through a series of carefully chosen factors. The Drake equation multiplies the rate of star formation by the fraction of stars with planets, then by the number of habitable worlds per system, and continues through the odds of life, intelligence, and technology emerging. It sounds almost mechanical when you lay it out like that, yet the result depends heavily on what values you assign to each step. Depending on how optimistic or conservative you are, the equation spits out wildly different answers. Some estimates suggest there might be only 1,000 civilizations out there right now, while others push the number toward 100 million. That is not a small disagreement. It is a gap so enormous that the equation becomes less of a calculator and more of a mirror for our own assumptions. If you plug in generous numbers for the rise of intelligence, the galaxy suddenly feels crowded with conversation partners. If you choose stricter values, we become a lonely accident drifting through an empty spiral arm. So here is the uncomfortable part. Even if we take the lowest credible estimate and imagine just 1,000 communicating civilizations in the Milky Way, that still means we should have picked up something by now. A single advanced species could theoretically fill the galaxy with signals or self-replicating probes over millions of years, which is a blink compared to the age of the universe. Yet our radio telescopes scan the sky and hear nothing but the background hiss of stars and gas. What happened to the 100 million civilizations that the math says might exist? Why is the sky so silent when the numbers tell us it should be humming with life? Maybe the assumptions behind the equation are wrong, or maybe something else is keeping the cosmos quiet. The next time you have a clear night, find a dark spot away from city lights and look up at the faint band of the Milky Way. Each of those tiny points represents a sun that might host a world, and a world that might host minds like ours. The Drake equation gives us a framework for turning that wonder into a rough calculation, and for opening a browser later to explore its variables for yourself. One 2023 update from the SETI Institute shows how the original 1961 formula still shapes discussions about detecting extraterrestrial intelligence today. But there is a growing tension between the math that dictates many civilizations and the observation that we have found none. That tension is the real heart of the Fermi Paradox, and it pushes us toward deeper questions about what limits life might face out there. Maybe the universe is not as empty as it seems. Maybe it is simply very good at hiding its inhabitants from each other. Let us imagine for a moment that Earth is not one of countless living worlds, but something far more unusual. Maybe the chain of circumstances that produced complex life here is so fragile that it almost never happens anywhere else. Perhaps our planet needed a large stabilizing moon, a magnetic field that deflects radiation, and billions of years of relative calm before anything like us could emerge. That is the rare Earth hypothesis, and it is a deeply humbling way to think about our place in the cosmos. But there is another possibility that does not require Earth to be biologically special at all. Imagine the distances between stars, not as numbers on a page, but as actual stretches of darkness that light itself takes years to cross. The nearest star system to our Sun is so far away that a signal sent today would not arrive until more than 4 years had passed. Now multiply that gap by the width of the entire Milky Way, and you begin to feel how isolated each planetary system really is. Here is the troubling part. If interstellar distances are the only wall between civilizations, then advanced species could still send out machines to explore for them. A self-replicating probe could land on an asteroid, build copies of itself from local rock and metal, and launch those copies toward other stars. Over cosmic time, such machines could spread across the galaxy without any living creature ever leaving home. So the real question becomes sharper. Why do we see no trace of them? If the rare Earth idea is correct, then we are simply among the first or the only ones, and the silence is expected. But if life is common, and space travel is hard yet possible through machines, then that silence starts to feel far less comfortable. Let me give you a way to feel this directly. When you look up tonight and see a bright star, you are not seeing it as it is right now. You are seeing light that left that star years ago, traveling through an emptiness so vast that the star could have vanished in the time it took the light to reach your eyes. That is the scale we are talking about, and it should change the way you hear the phrase empty space. The rare Earth hypothesis says the galaxy may be full of planets, but almost none of them have the long, stable history required for complex organisms. Most worlds may be frozen or scorched, or their stars may flare too violently, or their solar systems may lack the gentle gravitational order we enjoy here. In that view, Earth is not one neighborhood in a crowded city. It is a lone cabin deep in uninhabited wilderness, and the lights we search for may simply have no one to switch them on. Yet the distance hypothesis points to a different kind of loneliness. It says the universe could be teeming with life, but every inhabited world is trapped inside a bubble of space so huge that contact becomes nearly impossible. Two civilizations could live on opposite sides of the same galactic arm and never know the other exists, even if both listen for millions of years. The question of who is out there might have an answer, but we would never hear it. So where does that leave us? If the rare Earth idea is right, we are precious beyond measure. If the distance idea is right, we are not unique, but we are still profoundly alone in practice. Either way, the silence of the universe is not just a mystery to solve. It is a mirror held up to the fragility of our own existence, and that reflection will lead us somewhere even stranger when we consider whether civilizations live and die without ever overlapping in time. Imagine walking through a forest at night, where every rustle of leaves could be a creature, but you never see another living thing around you. The silence feels absolute, heavy, and strangely personal. That is the strange ache of looking into space and realizing that maybe civilizations rise and fall without ever overlapping in time. The universe is more than 13 billion years old, and our own Earth has been around for roughly 4.5 billion of those years. During that stretch, life has existed here for perhaps 4 billion years, an unbroken thread from simple cells to creatures who now build telescopes and ask questions. Yet the history of intelligent life on this planet is shockingly brief, a thin sliver at the very top of a vast column of time. Consider what this means for other worlds. Suppose a civilization somewhere around another star managed to flourish for 1 million years, which sounds like an enormous number until you place it against the age of the galaxy. If they arose 200 million years ago, they are gone before our ancestors learned to walk upright. If they are scheduled to appear 200 million years from now, we will be gone long before their first crude radio broadcasts leave their atmosphere. This is the sobering possibility that drives one of the quieter solutions to the Fermi Paradox. Maybe the galaxy is not empty because life is rare, but because long-lasting intelligent life is rare, and the gaps between civilizations are far wider than the civilizations themselves. 1 million years of accomplishment can vanish into geological time without leaving a single obvious trace that we know how to detect today. The forest metaphor becomes useful again here. In a forest, countless fires might burn over millions of years, each one bright while it lasts, but no two flames ever share the same patch of ground at the same moment. A traveler walking through that ancient forest might find charcoal under the soil and never guess how often the land had burned. We could be walking through a galactic version of that same silent aftermath, surrounded by the faint chemical ghosts of civilizations that ended so long ago that even their ruins have turned to dust. Or perhaps the flames simply have not started yet for most worlds, and we are among the first embers to catch. Science gives us no comfortable certainty in either direction, and that is precisely why the question lingers. But let me offer a small practice for your own mind the next time you are under a clear night sky. Pick out a single bright star, one that stands steady among the rest. Look at it not as a point of light but as a clock, because every star has a lifespan and some burn out much faster than others. Then ask yourself a tender and uncomfortable question. Could that star be 90% through its life, having already hosted a civilization that lived and died before Earth existed? Or could it be young enough that intelligent life will emerge there long after our own sun has expanded and swallowed the worlds around it? This is not a thought experiment designed to depress anyone. It is a reminder that the universe plays out across timescales that make human history feel like the blink of an eye. All our empires, our art, our wars, our music, and our mathematics could occur in the quiet gap between two other civilizations that never hear from each other. The loneliness is not necessarily emptiness. It might simply be rhythm, a cosmic breathing in and out where every breath is separated by an age that no mortal mind can truly feel. That may be the most poetic resolution to the silence, but it is not the most frightening one. Because if civilizations do not overlap because they die as often as they rise, then something might be cutting them short. And that thought leads us toward an idea far darker than solitude. Here is another possible explanation, and to my mind it is the most unsettling one. It has come to be known as the Great Filter. The logic is simple, even if the implications are staggering. Somewhere between the formation of a planet and the rise of a galaxy-spanning civilization, there is a barrier that stops life in its tracks. Perhaps this filter lies behind us in our deep past. Life appeared on Earth fairly quickly, but complex cells took over 1 billion years to emerge. Maybe that leap from simple bacteria to complex life is so improbable that it almost never happens anywhere. If we are the rare exception that squeezed through, then the silent sky is not a mystery but a relief. But consider the opposite possibility while your spine still feels safe. What if the filter is not behind us but waiting ahead in our future? That would mean most technological civilizations fail before they ever reach the stars. The universe is quiet not because we are early or rare, but because we are still being tested. The test has no do-overs and no guarantee of survival. Try this thought experiment on a quiet evening. Imagine a civilization very much like ours on a planet very much like Earth. They discover physics, build radios, and start listening to the sky. They celebrate their first nuclear reactor, their first space station, their first artificial intelligence. Then one of those inventions turns against them. They are not conquered by aliens. They are undone by their own hands, or their own machines, or their own appetite for resources. Their last broadcast is a warning, but no one else in the galaxy is close enough or quick enough to hear it. The forest of life grows silent once more. Now think about our own world for a moment and write down the dangers you believe could end everything. Nuclear war, engineered pandemics, runaway artificial intelligence, climate collapse, minuscule self-replicating machines. The list is not short, and every item on that list comes from the same source as our greatest achievements, our own intelligence. That is the twist inside the great filter. Perhaps the absence we hear in the universe is not the proof that we are special. It might be the evidence that civilizations like ours are common enough to appear but brittle enough to vanish. We search for teachers, we may be listening to a graveyard. And the hardest question is not whether the filter is real. The hardest question is whether we have already passed through it or are standing right at its threshold. You can look up at any blue evening sky and ask yourself that very thing. What would your own civilization write on its final page? And would anyone be left to read it? Sometimes the most chilling ideas come not from a laboratory or a telescope, but from the pages of a novel. The dark forest theory is one of those ideas. It began as a piece of speculative fiction and has since become one of the most discussed possible answers to the silence of the universe. The theory comes from the trilogy Remembrance of Earth's Past by the Chinese writer Liu Cixin. The three books are The Three-Body Problem from 2006, The Dark Forest from 2008, and Death's End from 2010. The concept was first defined in a systematic way in the second volume, and that is where the name comes from. The central metaphor is deceptively simple. Picture the universe as a dark forest at night, where every civilization is a hunter moving silently between the trees. You cannot see the other hunters, and they cannot see you. The moment you call out, you reveal your location to beings whose intentions you cannot know. The logic of the forest follows from two simple premises. Every civilization wants to survive, and resources in the universe are finite. When you combine these two ideas, the conclusion becomes brutal. Any signal you send into the dark could be heard by someone stronger who decides you are a threat. That is why the theory insists that every civilization must hide. Silence is not a mystery to be solved, but a survival strategy. The universe is not empty because life is rare. It is quiet because staying quiet is the only way to stay alive. Liu Cixin did not invent the idea from nothing, but he gave it a shape that captured the public imagination. Reviews in The Guardian and other major outlets praised the trilogy for its philosophical weight. The books became a global phenomenon, and the phrase dark forest entered the vocabulary of scientists and philosophers alike. If you want to understand the full depth of this idea, the best path is to read the trilogy itself. The Guardian's review from September 2019 describes it as one of the most ambitious works of science fiction in recent memory. The novels take the abstract logic and wrap it in a story about first contact and its terrifying consequences. But here is the unsettling part. You do not need to read fiction to feel the pull of this theory. You only need to look up at a clear night sky and ask yourself a simple question. Is the silence out there a sign of emptiness? Or is it the careful, deliberate quiet of creatures who know better than to make a sound? The Dark Forest didn't just sell well when the English translation arrived in 2015. It became the best-selling science fiction novel in the United States that year. And Liu Cixin became the first Chinese author ever to win the prestigious Hugo Award for Best Novel. That's not a small achievement for a book built around a single terrifying idea. The New York Times took notice, and so did millions of readers who had never encountered Chinese science fiction before. The book resonated because its central metaphor felt disturbingly close to something true. Let's think about what the theory actually demands. The universe is a dark forest, and every civilization within it is a silent hunter. Survival is not a preference, it is the first law of existence. Any species that reveals its location has made itself a target, because whoever finds you first might conclude that you are a threat. Trust is impossible without communication, yet communication is exactly what gets you killed. The logic closes around itself like a trap. Now imagine a distant civilization picking up one of our signals. Maybe it's a television broadcast from the 1950s, or a radar pulse from a military installation. They don't know we're curious and fragile and mostly harmless. They just know something is alive over here. What would a rational actor do in a dark forest? They would stay quiet, watch and wait, or they would strike first. We have been broadcasting our presence for over a century without ever asking whether that's wise. Radio waves from Earth have been expanding outward at the speed of light, announcing us to a galaxy we cannot see clearly. The dark forest theory suggests we might be like a child shouting into the woods at midnight. The forest has heard us. We just haven't heard anything back yet. And here's the twist. We have built enormous programs to listen for alien intelligence like SETI, while spending almost no effort on the question of whether we should be shouting. The search for life and the instinct for self-preservation may be pulling in opposite directions. So before you go online tonight and start dreaming about contact, ask yourself one simple question. If the dark forest is real, should we be making noise at all? So here we are, standing at the end of a long chain of possibilities. We have walked through the rare Earth hypothesis, the vast distances between stars, the rise and fall of civilizations, the great filter, and the dark forest. Each one offers a different answer to the same unsettling question, and each one leaves us with a slightly different feeling about our place in the universe. Some of these ideas are comforting in their way, while others are quietly terrifying. But the dark forest theory has a particular weight to it, because it turns our instinctive hope into a warning. The idea that the universe might be silent not because it is empty, but because everyone is hiding, that is a thought that stays with you. If that is the shape of reality, then every message we send out is a risk we are choosing to take. A civilization that survives for millions of years would not advertise its location. And maybe that is the most important lesson of all. When Fermi asked that simple question over lunch in 1950, "Where is everybody?" he probably did not imagine the answer might be something we should fear. Yet here we are, still looking up at the same quiet sky, still wondering why it never answers back. Maybe one day we will find a signal, and it will be the most wonderful discovery in history. Or maybe we will never hear anything, and the silence itself will be the answer. Whether the universe is a lonely place or a dangerous one, there is something strangely beautiful about being able to ask the question at all. We are a species that looks into the dark and asks who else is out there, even though we do not know if we truly want an answer. That curiosity is worth holding on to, because it is what makes us more than just a brief flicker of light in an enormous, indifferent sky. So keep looking up, keep asking where everybody is, and be ready for what the silence might be trying to tell you.